Let's go a bit deeper into our approaches. What are we doing? We want to get you quickly to sustainable ROI. We want you to benefit immediately from connecting the data you have and building the right applications for the right people. So we think that you can't tackle the problem by having a huge applications which solves all problems, but have really dedicated applications which either bridge gaps in your data where it isn't connected now, where we help you to connect it, or where it's in some Excel sheets now, which are of big use later in the system. So we want to bridge either the gap, or we want to help you to consume the application and directly to the problem we have. And that thinking led us to, first of all, to get something like the low-code approach that you can build an application quickly with really nice visualization elements we offer. And then, of course, to have an easy way of integrating the data into the system. And I will go in the next slides, I will go through the building blocks we use to achieve that. Like our super graph on top, like the graph the Spread Studio applications consume, is based on GraphQL. You might have heard it, but I give a really short introduction what GraphQL is. Basically, GraphQL is like a contract between a server and a client to request the data you have stored independently of the data source in a very flexible way. So this example I took from the GraphQL introduction, the documentation is really good. If you want to know more about it, just go there and watch the videos and read the documentation. But I will go through the base principle. So first of all, we define a schema. A schema is basically like the description for the client of what we have to offer. Now it always consists of a query and a type what to expect. So the query we see here is you want to refer to a user who is actually using the system, which is me. Like the type user is defined underneath. It has an ID and a name. And now the client is able to request that data and say, okay, I don't want the ID, but I want the name. And so you see how the request is formed, and the response is basically exactly the same, just filled with the information. But where is the data coming from? So as I said in the introduction, it's data source independent. So the server has something called resolvers. In the resolvers, you can define where you get the data from. So the data source is for the client irrelevant. So the client doesn't need to know where the data is coming from. This is the work of the server, and this is done by the resolvers. So in a nutshell, the GraphQL is defined by the schema is basically the contract between the data source and the client. The client doesn't know where the data is coming from, and resolvers can define where you bring this data together. If you heard before, in the video, that data-centric is one of our approaches, you might think of the upper left corner, having a monolith, a monolith applications, because we said as well, for example, you want to ensure that the access rights are correct, or that just the users and their authorization, just the users who are allowed to see the data get the data. But that's not the case. This is out of a Netflix blog where they're using GraphQL as well. And it shows a bit the evolution of architectures, and we see ourselves in the down right corner. We have a federated gateway with basically subgraphs underneath, which get the data from different data sources and are federated over a gateway. So that basically the maximal independence on the source side, but unified through the federation for the client side. The client side doesn't know, as said in the beginning of GraphQL, where the data is coming from. And here we can even split the service who serves the data and bring them together through a gateway. That's an important point to understand, how we do it. And we use this GraphQL schema as a contract, and it has different aspects. So here you see it's not intended to be read now, but you see a bit of the complexity of parts of our network and how do we find it. So we use the GraphQL schema as a contract, but how are we doing it and as a contract between what? So let's go into one of our elements, which is a component. So here you see that it's at the end, we can describe the node, what we have seen before, in the basics of a knowledge graph. So the node is described here with description, with the data type, and it gives you information what to expect there. And as well, that goes further. This component is then has like a logical connection and physical connection. So this is basically the description not just of the node itself, but as well how it's connected in the network and how it's interacting in the network and where it's placed. So as said before, like we are using a labeled property graph, and it's hard to define a schema for those. So we use the GraphQL schema, first of all, as a contract between the graph database and like how do we do that? So we have built a tool chain which basically uses a GraphQL schema to, on the one hand, aligns the database with the schema and generates the database we need with the fields we need. And on the graph definition, and on the other hand, we can generate the resolvers who use this database. So at the end, we start from the GraphQL schema, and we are able, through our toolchain, to use the schema to define the schema of the property graph underneath, and as well to generate the resolvers who are accessing the data as seen before, how it's done in GraphQL. And it's not the only way to do it. Of course, you can always overwrite like the generated code, and you can always manipulate it later. But the base idea is, okay, like we take the schema first to align the database and to generate the resolvers, which make us really fast in terms of schema changes and how we can adapt to new use cases. The second thing is, like the GraphQL schema is a contract between the graph database on the one hand, as seen before, and the data ingest. So if you are familiar with RML from the semantic web world, that was basically like an inspiration to define a mapping file where we can map the input. If we have a file, if we have a structure like here an XML input file, where we can map that at the end to the GraphQL schema and therefore to the graph database. So the only thing we have to do is, like when we get an XML file, to define this mapping file, which is really flexible in possibilities of finding the right information in the source file, and then to mapping it into the graph over the GraphQL interface. So we have different steps. First, we check in step 0 if the expectation of the files are met, like when you have chosen a mapping file. The next step is to basically go through the structure of the input file and map it to the new structure. In the post-processing, we see that we don't have duplicates by unique identifiers we have in our source file. And then in the next step is to find basically global uniqueness and just update the field which needs to be updated, or ingest new fields where it's needed. So this is how we use as well, on the one hand, the GraphQL schema, and how we use like principles which are as well used in the semantic web world for data ingesting through a mapping file, which is quite more extensive than RML is nowadays. And then we use the GraphQL schema as a contract, as we have seen, between the graph database, the data ingest, and on the other hand, as well with other customer data sources. So here we see, again, like the federated architecture I've shown before. And there you have the subgraph we define, basically through the resolvers. You can, of course, work on our system where we can use the power of the labeled property graph to do proper analysis on the data, for example, the error analysis and so on. And on the other hand, we can as well adapt quite easily to additional information from client systems, which we don't want to ingest in our graph. No, it's always a possibility of leaving the data where it is and basically virtualize it or abstract it through the resolver and the GraphQL subgraph, and the federation brings it then together. On top, we have our Studio backend, which consumes information from the federation, and then we build the app in the low-code environment, which I mentioned before. The low-code environment is enriched by a lot of widgets in forms of visualizations we have included to give the look and feel we have as well with our native applications. So at the end, there comes the GraphQL schema, and that's important again into play. So it's a contract between the graph database, the data ingest, and the other customer data sources, and most importantly, the applications on top. Now, by managing the interface quite carefully, we have the possibility of really easily scale applications on top, first of all with the technology as low-code, but as well with the trust on the API we are offering to get the information out of the system. So here we see a short demo, like how it is. That's, for example, one of our graph widgets, which you just drag and drop there, and then you can get visualization as you see, like in the top applications, and that makes us fast. And the API management southbound of it makes us scalable quite easily. Let's go back to our product solution. I repeat what we are offering here. Southbound, basically the connect of the data, the mapping through our tooling, like the schema definition, which defines as well the schema of the labeled property graph. The federation, which allows us to use multiple data sources, not just a graph, but like aligned with other data sources as well, which might fit better for the data we get. For example, time series data. Spread Studio, which relies on the schema and helps to build applications really, really fast. And on top, the applications which you face and where we can offer them directly to the needs you have to make your life a little bit easier, like with the applications, with the data at your fingertips at the end. Thank you very much for listening. I hope it was a bit interesting and you got some information how we use the technologies to build up our platform. If you have any questions, just reach out to us and let us know. Let us know your ideas. And yeah, let's talk if you're interested. Thank you so much. Bye-bye.